Okay, now in example number 2, we're going to estimate the value of the limit as t approaches 0 of square root of t squared plus 9 minus 3 over t squared. So I'm going to go ahead and put that in my calculator here. Okay, so I'm going to go ahead and put the function y equals. Now it's really important to make sure that you're using parentheses and grouping parentheses so you don't get any errors, because sometimes if you're getting errors, it's because the way you're entering the function into the y equals table. So here I'm putting in the function, okay, and I'm using x instead of t, okay, and I have parenthesis square root of x squared plus 9 parenthesis minus 3 close a parenthesis, and then I have my division here, and I'm dividing it by x squared, okay. And so now when I want to go to the table, okay, I'm going to put in some values here. Now, if I'm putting in values of negative 0.1, if I'm putting values of negative 0.01, if I'm putting values of negative 0.001, so these are all negative. Now if I'm going to choose positive versions of those numbers, 0.1, 0.01, 0.001, and even 0.05, okay, and let's go ahead and put in another one here. Okay. Well, I guess the calculator's kind of slowing down here, but anyway, as you can notice here, okay, the outputs are all close to what? 0.1667 and so forth, right? So what it's saying here is that as t approaches 0, okay, the values of the function seem to approach 0.1666666 and so on. Okay, so what we can do is we can guess that the limit as t approaches 0 of the function, the square root of t squared plus 9 minus 3 over t squared, again, is going to be approaching 0.16666, which is the fraction 1 over 6. So that's where we're guessing. Okay, now if you notice, okay, these are the table of values that we can put into our calculator, and I'm putting them there just so that you can see what we just did in our calculator. Okay, so again, you can see here that it's approaching 0.16667. Okay, now in example 2, okay, what would have happened if we would have had taken even smaller values of t? So the table shown here shows the results from one calculator, okay? You can see that something strange seems to be happening. If we start going smaller by putting in a positive and negative value of 0.0005, we get 0.168. Now if we go even smaller, plus or minus 0.0001, you get 0.2000. If we put in even smaller, plus or minus 0.00005, we get 0.0000. Okay, so if you try these calculations on your own calculator, you might get different values, but eventually you will get the value of 0, like we did here, if you make t sufficiently small. Now, does this mean that the answer is really 0 instead of 1/6? Well, no. The value of the limit is 1/6, as you will show in the next section. Now, the problem is that the calculator gave false values, because the square root of t squared plus 9 is very close to 3 when t is small. So in fact, when t is sufficiently small, a calculator's value for the square root of t plus 9 is 3.000, to as many digits as a calculator is capable of carrying. So something similar happens when we try to graph that function, square root of t squared plus 9 minus 3 over t squared, on a graphing calculator or on a computer. So if we look at the first parts A and parts B, okay, it shows quite accurate graphs of the function f, okay, and then when we use the trace mode, okay, we can estimate that the limit is about 1/6. Now, but if we zoom in too much, meaning if we look at these graphs C and D, okay, then we get inaccurate graphs. And again, because of problems with subtraction. Okay, so with this question, I definitely want to add how to use this on Desmos. So again, we're going to add a table. And then up here, we're going to put in our function. Instead of using t, we're going to use x. So you got your parenthesis. We're going to put in the square root of putting x and then 1, and then we're going to square that. And then plus 9, move your arrow, minus 3. And then we're going to divide that by x subscript 1 squared. And let's go ahead and put in our values. So we have 1.0. Well, let's put in negative 1.0. So we'll do negative 1.0 and then 1.0. And we have negative 0.5, 0.5, negative 0.1, 0.1. Then we have negative 0.05, 0.05. Okay, and then we have negative 0.01 and 0.01. Okay, so here we can see what the graph would look like, and we saw earlier how that represented. If we want to make sure that that represents a line here, let's go ahead and do that. So there is our line. Okay, now let's go back to what we said earlier in regards to what that function looks like when we zoom in on it using those other values. So those other values that are located in this table here. So if we put in negative 0.0005, okay, negative 0.0001, and positive 0.001, 0. Okay, 0. Okay, so again, if we look at our graph and if we zoom in closer and closer and closer, okay, then we start to see that same scenario that we saw previously when we zoom in closer, because again, we're looking at these values. So you can see what's happening. When we zoom out, we don't see that. But the closer that we get in, then we can see what's happening with that particular graph.